Hello my loves, how are you guys doing? I'm doing great. My name is Saifa, also known as Fentybeauty here on this channel, also on Instagram. Do follow me on both channels. Today we're doing a get ready with me to go absolutely nowhere, okay? Right after this face, right now, actually, I'm going to go rub it off and go to bed, yeah? Because it's already like, I don't know, 11, 10 something at night, you know? But you guys are gonna get ready with me. You're gonna get ready with me for nothing, yeah? In this video, we actually talked about not makeup, not much of makeup. We talked about science, we talked about some immunology, we talked about how a virus invades our system and what our system does to kill the virus, kill it, okay? I'm really sorry you guys that the beginning portion of this video was actually me doing my eyebrows and a bit of my eyes. Then I decided to stop that ish, okay? How do I force people to watch me do my eyebrows? My eyebrows are the most boring thing to watch. I'm sorry you guys have to watch the eyebrows only for this video, okay? Next video, I promise we're not gonna do eyebrows in the beginning. Oh, okay, this intro is already long enough. I hope you guys enjoy this video. If this is the kind of content you would like to see from me, if you'd like me to mix science and makeup together, it'd be great, you know. I'd do that. I'd love to do that, you know. I am a scientist, I am a biotechnologist, and this is my life. So basically, if you guys want me to give out some informative videos on actual science, then, you know, go ahead. Click that like button, subscribe, and also comment down below what else would you like to see. What other topic is like interesting to you when it comes to like pharmacy, when it comes to immunology, when it comes to... Let's not talk about plants, okay? I don't like plants. I mean, I like plants, but I don't like to study them or to work on them. So let me know what you guys would like to know, okay? See you guys. I hope you guys enjoyed the video. Bye. Today I decided we are in quarantine. We're having issues with viruses. This coronavirus is making people nervous. People are at home, they're quarantined. And I thought, you know what? Let's just talk about viruses, how they work, what they do, how they get into our bodies, how they get killed by our bodies. You know, let's just educate each other through this time. Maybe if you guys love this, we can make it into a series, like a science series, like a get ready with me with science kind of series. I'm also a scientist and I'm a biotechnologist, and maybe we can infuse these two together to make it into something special, something nice, yeah? Maybe. We'll see how it goes. If you guys like this kind of content, I'll keep making it, of course. We are going to talk about immunology. I love immunology. Duh, who wouldn't love immunology? Just tell me if you don't love to know how your system works and how you fight infections and how you fight diseases and how you fight every single day with everything that comes at you, because daily we are ingesting, we are breathing, we are touching, we are inserting food, we're doing so many things that are not good for us, you know. So many bacteria, so many viruses, so many just dirt, so much everything goes into our bodies. But why aren't we sick? You should ask yourself that. Why aren't we sick? If you just touch your door, the amount of bacteria on your door knob is scary, people. Scary. No wonder there's so many people who are like anti-germophobes, I don't know what. They have a point, because it's really disgusting things that are around us that we think are clean but are not, you know. So how does our body fight this? How does it? There's so much we can talk about when it comes to this topic. But you know what, let's start on the makeup. Let's start on the makeup. I completely forgot about the makeup. We are going to do my face, okay? Okay, I forgot a primer, so there is no priming today. Let's just do my eyebrows. I'm going to do my eyebrows using this pencil here from Urban Decay, the brow blade, okay? So of course you all know that you all know the types of cells you have in your body, right? But here we're going to be talking about the specific cell called the white blood cells. If you studied any kind of science, even in primary, I'm sure you know about white blood cells, yeah? White blood cells, mascari, they are like policemen, okay? They are there all around your body, looking for any kind of abnormal activity, an abnormal cell that gets in your body, any kind of antigen. An antigen is basically any kind of foreign substance that gives you like an immune response. Basically, it's something weird, it's something they don't know, it's something like, yo, who are you? Okay, when something gets into your body, the white blood cells are there, they're like, who are you? What are you doing here? You don't look like us. You don't look like you're from around here. You got to go. Okay, these are policemen. White blood cells are policemen just walking around our bodies, trying to save the body from any kind of foreign substance. Basically, from now onwards, I'm going to say antigens. White blood cells, there are three kinds. In school, back then, they don't tell you there are three kinds of white blood cells. First ones that I'm going to be talking about are the T cells. These destroy, like, yes, any foreign substance, or destroyed cell. Okay, these are there for that. And then there are the other ones called the natural killer cells. From the name, they just want to kill. They're there for the tumors, for the cancer cells, for the viruses. They see you, they kill you. They're not there to play games. They're called the NK cells in short. And then there are the B cells. These B cells, they make, I'm not laughing because they're stupid. They're not stupid. But they make the antibodies. I think everybody knows antibodies. Yes. They make specific antibodies for specific antigens. Antibody is made for a specific antigen. It's like a key and a lock. Okay? This key is only going to open this lock. It's not going to open any other locks. Okay? This antibody is only going to kill this antigen. It's not going to kill any other kinds of antigen. That's how vaccines work. Okay? They insert the virus into your body in a low dosage or something, dead, they can't reproduce or something, but then your body's like, oh, who's that? And then they're making these antibodies for this specific virus, flu virus, measles, whatever. Okay, so when they make these antibodies for this specific virus, these antibodies are now something normal in your body. They're there and they remember. Okay, the B cells remember. Next time that kind of virus comes in, they just know and they just come and kill it. You get it? These antibodies remember. That's how vaccines work. It's because of the memory. Okay, they can produce the antibodies faster, and then they can just come and kill it before the person gets sick or highly infected. So I got my brush here and I'm just gonna curve out my eyebrows. Anyways, back to viruses. When a virus gets inside the body, first of all, it has to look for a cell. It has to get inside a cell, okay, so that it can replicate and survive. Okay, you have to go in someone's house. There's where you're safe. So once they get into the cell, how do the other cells, how do the white blood cells, the T cells, recognize that there's something inside a cell? It's like they're hiding inside a normal cell. This is where the T cells come in. This is the first thing we're going to be talking about, the T cells. How do the T cells, these are called the cytotoxic T cells, how do they know that there is a virus inside the cell? They came out with this system that using major histocompatibility complex, in short MHC1, okay? This MHC1 take out proteins outside the surface of the cell, okay? They display a little bit of the protein from outside the surface of the cell. Now, if the virus is inside, they'll have little fragments of the protein from the virus on the surface of the cell. You understand? So when they're walking around, they see, uh-oh, inside there's a virus. Get it? Viral cells are not stupid. They know that these people know that we're here by our proteins coming out in the MHC. So they stop them from coming out and being displayed for the cytotoxic T cells to recognize and kill. Okay, this is where the natural killer cells come in. Let's do my eyes. Basically, now the natural killer cells are there. They're going around looking at cells, looking to see if there's anything abnormal happening. I'm using the nude palette from Hudabeauty. They're looking to see if there's anything abnormal happening with the cells, and when they go there and they see those cells that are infected, they're going to have less MHC molecules on the surface, because they're stopped, right, from coming out. They're going to have less. Okay, now once they have less, MHC is not there to play games. They're not sure if there's a virus inside or whatever, but you are different and you are going. That's how they work. You're going. So they're going to kill the cell just like the cytotoxic T cells kills the cell. They're going to work and they're going to just kill the cell because they have less number of MHC protein on the top. Faham? We understand? Okay, so once we're done with that, I'm just going to be putting this on my eyes. Now, there's another way that we deal with viruses or infected cells. The other way is by something called interferons. These are like proteins, okay? So the infected cell, the cell that has the virus inside, they release proteins called interferons. These interferons are there to stop the virus from replicating. The virus has to replicate, okay? Just one tiny virus is not going to do anything to you by itself, okay? So it's trying to replicate inside the cell. So they release these interferons to stop the viruses from replicating, okay? While they also do this, they also, by the same interferons, they tell the other cells around the infected cells that they tell them, basically it's like a signal. The interferons are like a signal. So these other cells here know that there's something wrong with you, okay? And to help you, okay, what they do is they increase their number of MHC cells around their surface. We already talked about MHC cells, okay? They increase, and basically the natural killer cell comes in and also spots the infection, because everyone around you has this number of MHC. Why do you have less? They kill you. Get it? Okay. Now the third way we eliminate, or our body eliminates a virus is by antibodies. Now the antibody can actually just bind to a virus, okay, bind to a virus before it even gets into a host cell. We were talking about them inside a host cell, so it can bind to them before they even get into a host cell. This way it actually stops them from entering a host cell, first of all, okay, and second of all, it can also form agglutination. Agglutination means like many antibodies stuck together with many antigens, or the virus, they're stuck together and they make like this big clot. If it's like a big sticking together, so many antibodies and antigens together, the T cells or all the immune cells, they can recognize the agglutination bind faster. Yes, something, it's bigger, it's more recognizable, so they help the immune cells to like find the virus. So yeah, basically the agglutination virus makes like a easier target for the immune cells to just go there and do their job. Antibodies do that. I'm going to take and do a cut crease, okay? I can't talk while I do this cut crease, so we're gonna skip right through it. I know, I'm not speaking, but I will speak, okay? I just want to like finish my eye so we can speak in peace, How did we just go from a purple look to adding some blue? But this blue looks like a black, so I'm just gonna add this to the outer corners. Guys, the reason why I'm keeping quiet throughout this is because I just noticed that if I forced you guys to watch me do my eyebrows, I was talking about viral inflammations in the beginning of the video while I was doing my eyebrows, so that's like, you guys, if you want to know this, you gotta watch me do my eyebrows. And you know what, it's not fun to watch someone do eyebrows. Not for me, I don't mind if someone skips through their eyebrows. That's why I don't show much of me doing my eyebrows on my videos, because you do them the same, every day. So, I'm sorry, you guys. You just start over. next time I'm talking, I won't start with my eyebrows. Oh, I'll come here like with my eyebrows done, I promise. Okay, so let me just finish with my eyes, then we can get right back into everything else. Alrighty then, we are done with my eyes. As you guys can see, I didn't want to bore you guys with the eyes just non-stop. Okay, what were we talking about? We were talking about do I have mic? Yeah, we were talking about the antibodies, the third way. Yeah, we're talking about the antibodies. We said first they neutralize the antigens, so they no longer can go inside the host cell. So you know, that's done. If they fail at that, they do the agglutination, which means they're binding together the antibodies and viruses. Okay, become big. Yes, they become big, and basically they become an easier target for the T cells to find. The third thing that antibodies can do is to activate phagocytes. Basically, they activate phagocytes, and the virus that's bound to an antibody, they bind to a receptor called the FC receptor. Once they bind to the FC receptor, they activate phagocytosis, which means they engulf, like eat up the virus and kill it. Okay, so in the beginning we did talk about antigens. What are antigens? Antigens is just any foreign substance that enters your body and triggers an immune response. An example of this is viruses, bacteria, snake venom. Okay, those all enter your body and trigger an immune response. Basically, your immune system is like, oh, you're new, we need to kick you out. Okay, this can also come from foods you eat, some types of foods, or people who have immunodeficiencies, basically immune problems. They can think their own cells are, their own cells are foreign. So that's our topic for today, how our body deals with viruses, basically. Okay, trust me, our body is prepared. It's working hard every single day to stop us from getting sick. Now, as you can see from the coronavirus, how many people are infected? I don't even know the number. So many. But how many have died? Guys, don't panic. From these numbers, we can see that our immune system is actually able to fight the virus, basically. So many people are getting cured, they're getting recovered. How it kills the other people is of course not yet known, because this is a new virus and even researchers don't know yet why they are dying specifically. They can see that, okay, many old people are dying from many of the people who are dying from the virus are actually old people. In America, I think that the youngest person to die from the coronavirus is 45 years old, and we don't know what was his problem. But people who are sick, people who have immunodeficiencies, people who have heart problems, people who have lung problems, these are the people that are at risk at dying from the coronavirus. Our body is able to fight it, so people, please don't panic. Yes, stay safe. I preach that all the time. Stay safe, because you don't know who you can infect. Maybe you can get better from it, maybe you can survive it, but how about your grandma? How about your child? How about your niece? If you don't have a child, how about your niece and your nephew? Whoever is, when someone is very young, the immune system is of course not strong enough to fight such a virus. When someone is already sick and they have different problems, health problems already, and old, of course they are more susceptible to getting this virus in extreme, to have an extreme case of it. Many young people have just a mild case. It looks like they just have a flu, they just have a little fever. Okay, so no need to panic. Okay, so from research they can tell that the coronavirus is just like a normal virus, basically like a virus of flu and measles. It's an RNA virus. It's an RNA virus wrapped in a protein shell. Okay, and once it gets into the body, it looks for a host, of course, and then tells it to replicate so that they can make more copies and infect the body. okay? And like humans, we reproduce, right? We get pregnant and we make babies from the father and the mother. The genetic material is coming together to make this new baby. But when it comes to viruses, they don't replicate like us. They divide, okay? They like divide and conquer. They divide, and basically one cell cuts itself and becomes two cells, similar cells, same. That's what they're trying to do, okay? Just replicate and become the same. And they keep replicating just like that. 1, half, 2, half, 4, halves, you know, just like that. But then many viruses such as the flu and stuff, or cold or something, they actually fail to replicate. They fail to replicate to the exact match as the mother cell, okay? Basically, if someone is trying to make another copy of me, okay, there's going to be something missing. There's going to be something that's wrong, okay? They make a small mistake, okay? Once they make a small mistake, they kind of change, because it's just a genetic material that they're changing. So they can change and they can evolve. They can become better. This is called mutation. They can either become better for us, basically, or they can become worse for us. People, don't be scared of mutation. People are scared, asking me about mutation. What if they mutate? Is that going to make it harder for them to make vaccines for us? First of all, from the research that I've seen, is that these coronaviruses are not mutating as fast as other viruses. Why is that? It's because they are proofreading their mutations. Basically, before they mutate, they mutate and then they look at it, okay? Proofread. They look at it and see, okay, if there's something wrong, something it's a mistake, they fix it. So they aren't mutating as fast as other viruses, actually like half. And this is also because other viruses cannot do that. Other viruses are much smaller than the coronavirus, which means basically the coronavirus has more tools in their tool bag to do different things. Maybe that's why they are like multiplying. Like, that's why they're conquering people and killing so many people and spreading so much faster, because they are different. They are bigger, twice as big as like the flu virus. They're bigger and basically they're a bit stronger. They have like different things they can do that other viruses cannot do, such as proofread. But proofreading is good for us because they're not mutating, they're not changing in a fast pace. So we can get like a vaccine and we can be like, we can try, you know, you're not always certain, but you can get like one type of vaccine that will work for this virus because it's not changing much. And I think the reason it's not changing much is because it doesn't have to, you know. Things change to get better, to fight something that they find is a problem. But these viruses are like, we're good, we're good. What we're doing, we are conquering this, we are thriving, we are going all around the world just the way we are. So they're not in a rush to change. They're not in a rush to change. They're not in a rush to mutate, and so they're not mutating and they're not changing. But maybe once we have like vaccines and maybe once we have like medication, they are going to try to change. The ones that survive, that's how it works, okay? They evolve also. They're smart. They evolve. We're nearly there, okay? I'm putting on a lipstick. This is Spice from Anastasia. So basically, yeah, this virus is new, people, okay? It's coming from animals. There's so many coronaviruses types outside in animals. So many. I think I'm done with my makeup, girls. So yeah, there's so many types of coronaviruses out there, so many. They're in animals. There's this theory that they say that they made this specific virus. Like, what did I call it? Terrorism, but biological terrorism or something? Is that what they call it? I'll Google it, okay? They think they made this on purpose to kill people, to terrorize some countries and all that stuff. Chinese people made it and all that. The other time I read that Beijing doesn't have it and Shanghai doesn't have it, but this virus spread all around the world. How did that happen? Yeah, how did that happen if the Chinese didn't do this on purpose to crash the markets in America, to crash in Europe, and they're not crashing? Yeah, because they say this because it's quite compelling how it happened. This coronavirus is from animals, and it resides in animals, and many animals have it, different kinds of coronavirus that cannot get into humans for a specific reason. They have to be able to have a structure to bind to our cells. Okay, once they come in, they have to be compatible with our cells, and it looks like this coronavirus is easily able to get into our bodies and infect us. That means like it has nearly the exact same structure with our cells to be able to infect us. Now, people are like, how did that happen? Yeah, this coronavirus, when so many other coronaviruses are not getting in us. How did that happen? We don't know. They don't know yet. Okay, so I don't know. I don't know. Could it be that they made this? I don't think so. You know, because it killed so many of their people. So I don't think so. But it's something that happened, and we have to take care of ourselves. Okay, I don't know what I was gonna say. Basically, the coronavirus is very good at entering humans and infecting humans and spreading from human to human. Okay, so we have to take care of ourselves, and we have to eat well. You guys should eat broccoli. You should eat all the greens because they help your immune system. These are not cures. These are not going to magically make you less susceptible to getting it, but they are going to help your immune system to work harder, because we need to protect and we need to help our immune system. It's already working so hard at protecting us from so many things. Yeah, I did a little bit of scarf. Yeah, so if you guys do enjoy me bringing you some science topics in this channel, please do let me know, so I would, you know, prepare more of them for you. Science is amazing, immunology is great, and there's so much we can talk about. Of course, this is just virus topic, but we can talk about so many things here ourselves. We can talk about bacteria, we can talk about food poisoning, we can talk about why we get fevers, we can talk about why we vomit, we can talk about why you diarrhea. Yuck. We can talk about so many things that are very crucial to learning. You have to learn about your body and how your body works. Okay, so you know how to better yourself, you know how to keep yourself healthy. That's important. Not just beauty, you know, you have to have beauty and brains. Yeah. Yes. So this is the finished look, you guys. I used two palettes. I used this Hudabeauty palette. From the Hudabeauty palette, I just used this purple shade, this shade right here called Playful, and the Crave is the glitter like underneath. And from this palette, I used, this is the Fentybeauty Snap Shadows. I use this blue color here to the outer corner, and I use some of this to just highlight the inner corner and under my brow bone. And I don't know if you guys would like to see the rest, but I'll put them in the description what else I used for this video. And please guys, please do share this video. It's important for people to know. It's important for people to know. It's a good lesson to know how your body deals with stuff. So please do share it. I would really appreciate it. Don't forget to subscribe and like the video, and comment down below what other topics would you like to see. I'm a biotechnologist. We can talk about a broad, so much science. We can bring so much science into this channel. If you guys enjoy it, we'll make this into a series. Okay, see you guys later. Bye.